Here's a question that might have bugged you for a while. You look at Hiroshima and Nagasaki today, and they're vibrant, bustling cities. People live there, work there, raise families there. But then you look at Chernobyl, and the area around the old power plant is a total ghost town, an exclusion zone. How does that make any sense? Well, today we're going to crack that exact paradox. So this is the big question, right? It feels counterintuitive. You'd think that a nuclear bomb designed to cause maximum destruction would leave a place uninhabitable for far longer than a power plant accident. But the reality is completely the opposite. Let's get into why. All right, to really get to the bottom of this, we've got to talk a little bit of science. Don't worry, we'll keep it simple. It all comes down to understanding this invisible threat at the heart of both disasters: radioactive fallout. So, at its very core, what is radioactivity? Well, you can think of it like this. You have these tiny, unstable atoms that are just falling apart. And as they decay, they spit out this powerful, invisible energy called ionizing radiation. That's the stuff that's dangerous to us. But here's the thing. Not all radioactive stuff is dangerous for the same amount of time. And that's where this crucial idea of half-life comes in. A half-life is just a countdown. It's the time it takes for half of a dangerous substance to simply decay and disappear. A short half-life means it gets safer faster, but a long half-life, well, that's a whole other story. To put this into perspective, let's look at one of the main villains of the Chernobyl disaster, an element called cesium-137. Its half-life is 30 years. 30! That means that today, more than 3 decades later, about half of the cesium-137 that was blasted into the environment is still there, baked into the soil. This one fact is a huge reason that exclusion zone still exists. Okay, so with that bit of science under our belts, let's dive into our first case study, the atomic bombs dropped on Japan. Now, this is probably the single most important detail in this entire explainer, so listen up. The bombs never actually touched the ground. They were exploded way up in the air, hundreds of meters high. This is called an airburst, and honestly, it makes all the difference in the world. So why did they do that? It was a strategic decision. The main goal was to create the biggest possible shockwave to flatten buildings. By detonating so high up, most of that radioactive material, the fallout, was shot way up into the stratosphere. From there, it was scattered by global winds and diluted over the entire planet, instead of concentrating on the ground below. Now let's pivot and talk about a completely different animal, the Chernobyl catastrophe. The key phrase to remember here is ground-level disaster. And this is absolutely critical. Chernobyl was not a nuclear bomb. It was a reactor at a power plant that suffered a catastrophic steam explosion and then caught fire. And unlike the bombs in Japan, this all happened right there on the surface of the Earth, blasting its radioactive guts directly into the surrounding soil, forests, and air. So let's just put these two side by side. On one hand, you have an airburst weapon. On the other, a ground-level reactor malfunction. But look at that last row. The amount of radioactive fuel. The Hiroshima bomb had what, a couple of kilograms of fissionable material? At Chernobyl, we're talking about hundreds of tons of nuclear fuel and contaminated debris that was released. The difference in scale is just, it's almost impossible to wrap your head around. But wait, the story isn't over. There's another piece to this puzzle that really helps bring it all into focus. And that's the more recent disaster at Fukushima in Japan. Now, you might be thinking, hang on a second. Fukushima was also a ground-level reactor disaster, wasn't it? And you'd be right, it was. So why isn't it just another Chernobyl? Why isn't there a permanent massive exclusion zone around it too? The answer comes down to one word: technology. Or more specifically, containment. You see, the Chernobyl reactor was an old Soviet design. It had practically no containment structure. When it blew, the burning core was just open to the sky. The reactors at Fukushima, though, were built inside these massive reinforced concrete containment buildings. And while they were badly damaged, they did their job. They prevented a release on anywhere near the same scale as Chernobyl. Okay, so we've looked at the science, the bombs, the reactors. Let's pull all these threads together now and give a final, clear answer to that question we started with. When you boil it all down, it's really about these three things. First, altitude. Was it high up in the air or right on the ground? Second, the sheer amount of radioactive material involved, a couple of kilos versus hundreds of tons. And third, technology. Was there a modern containment building to bottle up the worst of the disaster? So if you take away just one thing from all of this, let it be this. Not all nuclear events are created equal, not by a long shot. The word nuclear itself isn't a monolith. Understanding the context, bomb versus reactor, airburst versus ground level, that's everything when it comes to the long-term consequences. And that leaves us with a final thought. These events, they're not just history. They're powerful, painful lessons. So knowing why the outcomes were so drastically different, what do you think is the most important lesson we've truly learned, or maybe should have learned, from our nuclear past?